Hi, in this video we're going to find an unknown side length of a right angled triangle. Now we explored an example of this in the previous video, but this one is going to be just slightly harder. Now remember what step one was. Step one is to label the sides of the triangle. Now let's identify what the angle of interest is first. Well, we ignore the 90-degree angle, and this is the angle of interest, the one angle that's given, and then we label the sides relative to that. Now we can see that this side given here, 5 centimeters, that's opposite this angle, and that's known as the opposite. So let's put O for opposite. Now this side is not labeled, so we can ignore it. And this side has got the X on it. Now the longest side of the right angle triangle is known as the hypotenuse, and we put an H for hypotenuse. The hypotenuse is always opposite the right angle in the triangle. Now, we didn't involve this side, but if we were to, notice this side is next to this angle of interest of 50 degrees, and so we would label it as the adjacent. Adjacent means next to, so we put a little A there, but it's not involved. Now, step two is to select the correct trigonometric ratio. I'm just going to put trig for short. So these are trigonometric ratios, and remember sine, cos and tan are special function machines, number machines, which take an angle, the angle of interest. So this angle of interest is the theta. Theta is just a Greek letter of the alphabet, but we use it for angles quite often. So sine, cos and tan are special functions, special rules that take the angle of interest and gives you the relative size, the ratio of two of the sides of the triangle. So it might be the relative sides of the opposite and the hypotenuse, or the adjacent and hypotenuse, or the opposite and adjacent. And remember, the nice way to remember it is this mnemonic, SOHCAHTOA, because sine of the angle is opposite over hypotenuse, etc. So in this particular case, we've got the opposite and the hypotenuse. O and H, we can see it's this one here, so it's sine. So we let's write out this first, and then just substitute into this formula. Now, the angle of interest, the theta, is 50 degrees. So we've got sine of 50 degrees is equal to the opposite. The O is 5 over the hypotenuse, which is X. And what makes this slightly hard this time is that the variable of interest is in the denominator. Now, I'll do it the slow way, and then I'll do it the sort of quicker way. If you want to do it the slow way, I don't like the fact that we have this fraction here and we've got over x. So to get rid of the over x, we could multiply both sides of the equation by x. And if we do that, the left-hand side becomes x sine 50 is equal to, and then we times the 5 over x by x. That just gets rid of the over x, just leaving 5. So we get that. And now I want to get the x on its own. Now the x is being multiplied by sine 50. So to get rid of the times by sine 50, we divide both sides by sine 50. And then the left-hand side just becomes x. And the right-hand side becomes 5 divided by sine 50. Now don't worry how your calculator works out sine of 50. You can just put in your calculator 5 divided by sine of 50, use the sine key on your calculator, and that gives you 6 point, how many decimal places? 1 decimal place, so 6.5 centimeters. So that is the final answer. But if you just want a slightly quicker way of doing this, it's to do this. Now, if I had, say, the numbers 4 is equal to 8 divided by 2, how could you rearrange those numbers in a way that still makes it true? Well, you could swap the 4 and the 2, couldn't you? And so you get 2 is equal to 8 divided by 4, which is still true, isn't it? So in general, when you have a division like that, you can swap the thing you're dividing by and the result of that calculation. So that's the same here. We can swap the thing we're dividing by and the result of the calculation. And that gives you x is equal to 5 divided by sine 50. And you can see that we get what we had over here, but a lot more immediately. I call this the swapsy trick.